Physical hydraulic modeling is a design technique used by engineers to optimize the design, to ensure the safe operation of the system, and to facilitate the decision-making process. When the same fluids are used in the physical model and in the prototype, the Pi-Buckingham theorem implies that the two most relevant dimensionless numbers in hydraulic modeling are the Reynolds and Froude number. In flow with a free surface, gravity effects are always important and a Froude number modeling is applied. A Froude number modeling is typically used when friction losses are relatively small and the flow is highly turbulent, for example overflow weir, flow past bridge piers. A main concern is the potential for scale effect induced by viscous forces, and a distorted Froude similarity may assist to reduce the risk of scale effect. A distorted model is a physical model in which a geometric scale is different between each direction. Often, river models are usually designed with a larger scaling ratio in the horizontal direction than in the vertical direction. That is XR being greater than ZR, XR the horizontal geometric scaling ratio, and ZR the vertical geometric scaling ratio. When the acceleration gravity is constant, a distorted scale model implies that the Froude number is the same model on prototype, or the ratio of the velocity scaling ratio to the square root of the vertical geometric scaling ratio is equal to 1. Other basic scaling ratios are shown, and in particular, note that the longitudinal slope, theta, differ between the model and the prototype. In addition to the economical and practical benefits, the distorted Froude similar models have a number of advantages compared to undistorted models. The flow velocities and turbulence in the model are larger, the time scale is reduced, the model Reynolds number is larger, improving the prototype to model similarity. The larger vertical scale allows a greater accuracy on the water depth measurement. Practically, the model distortion, that is the ratio XR over ZR, should be typically less than 5 to 10, and the disadvantages of distorted model should not be ignored. The modeling of flow resistance is critical. For a distorted Froude similar model, the flow resistance scaling ratio should fulfill the following relationship. Importantly, the model flow must be turbulent when the full-scale flow is turbulent, as indeed laminar and turbulent flow exhibit seminal differences. The concepts of physical modeling and Froude similitude are essential knowledge to the application of open-channel hydraulics. They are discussed in the relevant YouTube video movies in the same playlist.